Right. Well, hi, I'm Denis Tkachenko. I am a senior lecturer in the Department of Economics at NUS, and I'm teaching currently two classes in the quantitative specialization. They are EC 4304, Economic and Financial Forecasting, and EC 4308, Machine Learning and Economic Forecasting. So a lot of stuff about forecasting, but they're basically applied econometrics modules. So although quantitative specialization sounds like, pretty homogeneous, right? I was looking at it the other day and I realized that it's kind of, you can think of it as consisting of two parts, right? The first part is the kind of the quantitative theoretical economics, right? So this is modules like mathematical economics, advanced micro or macro, right? The 4000 micro macro. And then I guess at the 3000 level you have game theory, right? And then at the 4000 level you have search theory, right? So these are very sort of high level economic theory modules, right? And so for those kind of modules, it's paramount to be very comfortable with mathematics, right? So things like basic calculus, a bit of, optimal control theory that you learn in your econ modules, right? But the person has to be ideally, mathematically minded and at least be very comfortable with mathematics, right? Then there is the other side of the quantitative specializations. If you look at modules like Econometrics 3, Economic and Financial Forecasting, and Machine Learning and Economic Forecasting, the latter two I actually teach, so I kind of know what I'm talking about. I would say in those modules, mathematics is important, but perhaps to a lesser extent, right? So particular areas become more important, such as calculus and maybe a bit of linear algebra. But what's more important comparatively, I think, relative to the other modules, is that you must be much more comfortable with things like statistics, right? So manipulating probability distributions, finding out expectations, variances, covariances, just having general appreciation of randomness and probabilities and estimators, their sampling distributions. That becomes much more important because those are basically modules in theoretical and applied econometrics, right, where they're applied to mostly time series data. But of course in machine learning there is also a big role for cross-sectional data. So in terms of, where do the skills come from? There's no need to panic in some sense, right? Some students panic, they say, oh yeah, I'm not strong in this or that. Actually, all those preliminary skills, they are imparted to you in the early years of your studies, right? And so my sort of advice to students who are thinking about these specializations is to take your core module seriously, right? So don't just, try to maximize your score by memorizing stuff, but actually do put in a bit of extra effort and try to understand what's going on, right? What is an estimator? What does it mean for an estimator to be consistent, unbiased, asymptotically efficient, this kind of stuff? It sounds boring when you're taking the core module, but it actually becomes instrumental in being able to progress to more advanced topics when you start doing specializations. Yeah, so in general, right, there is a good mix. So I know a little bit less well the sort of the mainstream econ side of the quantitative specialization, but I assume that in the 4000 micro and search theory, you kind of get a good mix of both, right? So you study very rigorously the theoretical concepts, and then you do see some application. I can speak for the econometrics side, right? The econometrics 3 depends. By design, it's supposed to be a little bit more theoretical with some application, but I would say the theoretical component would be at least 50 to 60%, right? Economic and financial forecasting and machine learning are extremely applied modules. in my mind, as a theoretical econometrician, right? It doesn't mean you don't do theory, but you just do enough theory to be able not to make silly mistakes in applications, right? Because when people say, oh, I want to do an applied module, right, the natural question is, what is it that you're going to apply, right? So you first have to have at least a basic idea of, how these methods are set up, when do they work well, what are the assumptions under which they work well, right? Conversely, when this assumption is not satisfied, right, one would not be wise to use those methods. But both modules feature a very extensive programming component, right? The forecasting currently relies a lot on Stata to leverage the knowledge from 3303 and 3304, that's econometrics 1 and 2. And the machine learning, obviously to sort of be in line with the industry standard, is done entirely in R. So that is, open source language, and so all the coding is done in R, which, you can port to anywhere. It's open source software, doesn't require a license, and a lot of companies, actually use it. But if they don't, then it's relatively simple to, migrate to Python or whatever other framework they may be using, because once you know what to do, how to do it is just reading the manual, basically. So, in addition to what the degree itself offers you, I would say that some of the classes in the economics specialization may gear you up a little bit better for jobs that require some sort of quantitative analysis, right? So those would be jobs in probably financial sector, where I had students who went on to work at trading desks, and some students actually went on and to work in the Monetary Authority of Singapore, right, in the forecasting division. So they have reported, in general, students have reported that very often, right, they get questions from the interviewers that they're able to answer because they took the forecasting class. The machine learning class, I cannot say much because it's very new. It was offered for the first time last semester. But I think this is the class that has a very high potential, because these days, everybody is moving to some sort of form of data-driven decision making. And so having somebody with, at least the basic knowledge of, how to analyze data, predict based on some kind of set of variables, that becomes an increasingly attractive skill, and I think also an increasingly in-demand skill, right? Because these days the infrastructure, has caught up with the sort of advances in the field, so anybody can run these machine learning libraries easily from R or Python, right? So you don't have to be a computer science major to do that, but I guess the value added that people bring to that process is, right, thinking about, the approach, does it make sense, what data transformations I have to do before I apply this approach, and which variables to consider and how to interpret the results, right? What do they tell and what do they not tell you? That's quite important. I would say it can lead to opportunities in all three of these. Whether it leans particularly to one or the other, I guess, can be to an extent controlled by the student, right? So as I said, if you want to be sort of a very pure academic, who wants to pursue a PhD, and you want maximum rigor, right, you can sort of bias your course choices more towards microtheory, mathematical economics, game theory, search theory. Those would be sort of good preparation for a graduate degree. You can still find, applications in the private sector, right? I've heard of students doing very well. Those would be PhD students, but PhD students who've done like game theory as their main field still landed in like an investment bank. So it's not like it excludes you from those opportunities, but I would say it will be good preparation for graduate studies. Conversely, you can sort of make it a little bit more applied, right, by taking a couple of these econometrics oriented classes and maybe one micro, macro, depending on your main interest. And this would be sort of leaning more towards the private sector, the jobs that require quantitative and analytical skills. And then the public sector, that depends entirely on which ministry or division you're applying to, right? But you can still tweak in a way that, to make yourself a little bit more attractive. As I mentioned, right, I had at least one student who successfully got a job at MAS in the forecasting division, right? But of course, they have different divisions, and so different skill combinations can be demanded in those. Okay, so I guess we should begin by probably assuming, right? I think it's true, but let's assume because we're economists, that if you want to work in finance, right, the work in finance, quote unquote, is not a homogeneous field, right? There are positions that are more sort of on the quantitative side, right, the so-called quants, where you basically churn out some numbers all day and trying to get a model that predicts better or fits better. There are positions that are more geared towards just serving the macroeconomic conditions and trying to make sense of it and disseminate information. Well, so if you want to sort of put those skills in action, right? So it has to be done through coding. I don't like the way people say, "Oh, I want to learn coding," right? Because coding in itself has almost no value, right? If you're good at coding, the only thing you can do is you can speed up the program, right? But these days the computers are so powerful that oftentimes that's irrelevant, right? It's much more important, what to code, right? And to be able to specify a particular input and correctly interpret the output, right? That's the value-added skill. And this is why, people are looking for econ graduates for certain positions that may involve like a data component rather than computer science graduates, right? Because computer scientists, they excel at, processes, architectures of computing, and they can make these things happen, right? But they lack the domain knowledge, right? So this is the kind of the trump card of economics degree, right? So you do have the basic coding ability that's enough, for you to do what you want to do, right? But you have this domain knowledge that enables you to sort of, curate what methods you use and how you interpret the output and how you act on it, right? And yeah, so it doesn't really matter, whether you learn R or MATLAB or Python. Coding skills are easily transferable between environments, right? As I said, it's just a matter of reading in the manual. Once you have the actual ideas in your head about what you're trying to do, right? Or I want to, implement this particular non-parametric method, right? How do I do it in this program? Well, then it's simple, right? Download these libraries and that, and this is the syntax. From a purely, like computer science guy, right? He wouldn't even know what method to use for this particular problem, right? Because he lacks the domain knowledge. He doesn't know, well, this series is not stationary, so I have to stationarize it first. I make it stationary first, and then, maybe apply this particular method because this particular aspect of data is important in this particular application. Take your core modules seriously, right? Don't just kind of study to pass an exam and then forget, right? So things like 2303, 2104, right? The stats, the math, obviously the core economic courses, right? But for the sake of, say, econometrics classes, right? I more mean like 2303, so the foundations for econometrics, and then 3303 and 3304, those are econometrics 1 and 2. Really try to understand what's going on there. Don't just memorize and then spit it out on the test, and a month later you have no idea what happened. I do get students like that in my class, and then they find it extremely difficult to adapt, and they say, oh no, but this is such a jump. And I'm like, no, you actually have done this before, you just don't remember it because your approach to studying was one that is probably maximizing your grades without, I would say, maximize understanding. Yeah, don't stress too much about your grade. Grades are important, but grades are not everything, and I would rather work with a student who has a good understanding of the methods and the assumptions behind the methods, right? Rather than the student who is very good at test taking, right? But may not be actually, intuitively understanding what's actually going on with all that technical machinery. So that's one piece of advice. And the other piece of advice, I noticed that students tend to study in bursts, right? So you do nothing for 6 weeks, and then you have your first homework or whatever, and then there's an explosion of activity, and then there's a lull again, and then there's an explosion of activity before the project and the final exam. I would recommend it, especially these quantitative subjects, right? They sink in a bit slowly. So if you just do a review every week of what has happened in the lecture, and for the classes like forecasting and machine learning, a great thing to do so is to just go over the code of the lecture, right? Because I post the code that replicates every result seen in the lecture. And if you just go through it, at a slow pace and make sure that you get everything that happens, I think that really helps. And then you don't need to study that much before homeworks and exams, because it's like consumption smoothing, right? Basically the same idea. Smoothing is always better than kind of extreme quantities with breaks in consumption, right? So the consumption of knowledge is quite similar to the usual consumption.